Welcome to clickmyproject.com. Now we discuss about the product false discovery rate approach to unsupervised image change detection. Now we discuss the abstract for the process. The main purpose of this project is to detect the change occurred in the land area. In the most of the satellite images, the changes will be monitoring for several hours. In such cases, we can take the first image as an input for the land of olden year, and the second image is taken from the land satellite image from the new year. The change between the previous and the present image is detected, and then the detection is indicated. This process is implemented for this purpose only. To monitoring the land area, it is better to detect whether the changes occurred in the land area is dangerous or not. In this system present a novel approach technique for supervised and supervised change analysis that leads to an method of ranking the changes that occur between the two satellite images acquired at different moments of time. We already discussed the two moments of interval time objects is taken from the satellite images. The existing systems of the change analysis used to change vector analysis technique. That is this framework based on the representation of the CVA in polar coordinates. The proposed system of the change analysis is based on the binary descriptor and using the Hamming distance as a similarity matrix. The one thing is the Hamming distance is most commonly used and the most efficient process to determine the distance between the changes occurred in the each and every pixels in image. Hence, this process is well efficient to determine whether the changes occurred in the particular region or not. Now we discuss the flow diagram for the process. This is the overall flow diagram for the process. At first, the input image is taken from the dataset. This is not mentioned in the flow diagram. After getting the first image from the dataset, the binary descriptor B1 is created, and then the second image is also taken from the dataset. The one thing is the dataset consists of major images like satellite images, which consist of the changed images as an early time period. After getting the second image from the dataset, the binary descriptor is created for the second image as an B2. After the binary descriptor image getting from the input image, the Hamming distance is calculated between the B1 and B2. The B1 is the binary descriptor 1 and the B2 is the binary descriptor 2. The distance between these two images is known as the Hamming distance. After applying the Hamming distance, the quantization is taken for the Hamming distance image. Then the quantized image is undergone for the process CIM. The CIM is abbreviated as an change intensity map. In the change intensity map only, we have to classify the areas differ from the one image to another image. After the change detection, the estimation parameters such as the accuracies of the process and then the correlation between the two images is calculated. Now we discuss the initial running procedure for the process. At first, open the MATLAB 2013 and change the directory as in the code. You can see the mainfile.m in the current directory. If you want to execute the code, right click in that file and you can see the option run. Select the option run to execute the file. After completing the running procedure, you can see the datasets folder. Open the dataset folder and select the first image from the dataset and click the button open. Now the selected image is shown in the figure 1, and then you can select the second image from the database. Now I can select the second image from the dataset. Now the corresponding results are shown in the figures. Now the total number of process done in the overall working process will be shown. Now I can explain the one by one in the figure wise. In the figure 1, we can select the first image. That image is shown in the figure 1. Then the second image which we have selected is shown in the figure 2. Then the resized image for the first image and the second image is shown in the figure 3. Then the filtered image for the image 1 and the image 2 is shown in the figure 4. Then the binary descriptor image shown in the figure 7 for the first image. Now the binary descriptor for the second image is shown in the figure 9. Now the Hamming distance between these two images is shown in the figure 10, as well as the pixel values of the distance will be shown in the table format. Now in the figure 11, we have to select the respected change region like this and select that area. Now the selected area is shown in the figure 12. Then we have to select the separate region from the figure 2. Now the both region which we have selected is identified as a change region. Those change region will be correlated from 1 by 1. After selecting the respected region from the figure 1 and 2, the clustering process is done. The clustering process will take some more time to cluster the region, like whether the region is the grassland or whether the region is glaciers, like that. After the clustering process, the change intensity map for the different levels is shown in the figure 19. Now the overall accuracies for the process and the SNR values for the process is shown in the figure 20 and figure 21. Now the existing and proposed comparison between the accuracies will be shown in the figure 22. Thanks for watching this video.